Hello.
Yes, ma'am. We are live now. Please start.
Okay. Good evening, everyone. I'm Neelima Agarwal. I'm working as a faculty in Department of Physics, CBIT. So I would be continuing once again our discussion on Mathematica, which we are doing in the last tutorial we have done. And I would really strongly recommend all the learners and educators, those who have enrolled for this course on classical mechanics, to use Mathematica for their computations or for cross-checking the computations which you are doing in this course, or also you can use this software in any other course which you are doing. So last time we had some network issues. So this time I have recorded some parts of the tutorial. Okay. So if you have any questions, you can always write in the chat box. Balaji, you can play the video. Before starting today's tutorial, I would like to emphasize once again that there is no need to buy the software Mathematica in order to check your computations or do anything. You can always sign up free in wolframcloud.com and then you can use Mathematica. Okay, so now I already have an account. So I have signed in, and then you can open a new notebook. So let us open a new notebook. Okay, and then you can name this file. Okay, so now I already have an account. For example, Mathematica. So I have signed in. Tutorial 2. Okay. Now, first I would like to give, for example, some heading. Then you can choose format, input, and then title or anything you can choose. Now, so what would be our today's plan for this tutorial? So there are many learners who have joined late. So I thought I would quickly recap few important functions which we did in the last tutorial. And few learners were facing some problem. So first I will give a quick recap of some important functions like plot, table, and manipulate. These are few functions which you require very often to do your computations. Then, you don't have to go out of this cell. Everything which you write in Mathematica notebook is in the cell. So this is my cell for, I have chosen this for title. So if you go out of this cell, then it will not be title, it will be code. Okay. So then we would see how to input a matrix in Mathematica, because you require a lot of computations with matrices you encountered in week 3 and week 4, and you require some familiarity with that. That would be very useful for you all. Okay, so we would be dealing some matrices. We can check some important properties, how to take a transpose of matrix, then how to take determinant, then you can take trace, you can find the eigenvalues, you can find the eigenvectors, also you can find the inverse. These are the few important things which you require very often. Inverse. Okay, then we'll try to see different kinds of matrices. Symmetric matrix,
antisymmetric, orthogonal, positive definite. You all have encountered this while doing the lectures of week 3 and week 4. Okay, and then finally we'll try to see how to diagonalize a matrix with the help of Mathematica. Of a matrix. So this is roughly today's plan. Okay, we'll see. Now you can always change the font of the headings, whatever notebook you are making in Mathematica. So from here, for example, if I choose 36, you can take. Now you come out of this cell, okay, and then we'll start. So let us try to do a quick recap of few important functions which we did earlier. Let us try to see plot. Okay, you can always close this, or you can change the font. Here you have to choose code and then plot. Okay, now I would like to plot a sine function. In Mathematica, whatever inbuilt functions you use, you always have to start with capital letter and the arguments will be enclosed in the square brackets. Okay, now what I would like to plot, for example, sine x. Sine, the argument will again be in square brackets, comma, then I need to specify that x varies from, let us take, minus 2 pi to 2 pi. Okay, and in order to run this, I need to do shift enter. Okay, it will ask, do you want to automatically evaluate all the initial cells? Yes. Okay, this is how you plot in Mathematica. Now if I would like to plot, you can see, if you are studying any function and you would like to see how the plot looks like, you can do this. For example, I would like to plot two functions here. I also would like to see how cos x varies. Then shift enter. It has given an error. An option must be a rule or a list of rule. If there are more than one function, then always you have to enclose in a list. And a list is written by use of curly brackets, all the functions separated by all the entries, functions, or anything separated by commas. So here I will put a curly bracket closed. Now if I run this, it will show me the plot of both the functions. This we have already discussed. Okay, now you can play with this function plot. You can see you can label the plot by using command plot legends. Then you can explore accordingly whatever is your requirement. You can also shade this. Okay, you can do a lot of things. Now instead of functions, for example, if I would like to plot a list of data, then how do I do that? That also I can do here, because when you do a lot of experiments in the lab, then you require to see sometimes that how your data is changing. That you can do here. So first, in order to produce the data, there is a important function known as table. Okay, so again I'll just change the font size so that it is visible. Table. Let us try to see function, for example, n cube, and then I require the data. My function is n cube and I require the data, for example, from 1 to 10. Okay, I need to specify what is varying from 1 to 10 n. So this is my list of data. Now I would like to plot this. So there is another important function known as list plot. Okay, and then you can copy. For example, I would like to plot the same thing here. Sorry. I would like to copy this and then here. Okay, again list plot. Whatever you are writing, whatever you would like to plot is enclosed in square brackets. Then inside, what you have to plot? Table, again square brackets, and then you need to specify the value of n. Okay, now if I run this, it has given me the plot of this data points. Now I would like to join these data points. So this table, this square bracket ends here. Okay, this end square bracket is for the list plot. So here in between I'll write a comma and then open and close curly brackets, and then I will write, there is no need of curly brackets because I don't have any list, joined true, that you need to join the data points. Okay, so this is how you will plot the data points. Okay, so these are two very important things. Another thing is that, for example, I have a function here sin x, and I would like to plot from x minus 2 pi to 2 pi. But sometimes it happens that I need to see that how this function varies with some other parameter. For example, I have sin nx. Okay, and I would like to see that how my sin x from x minus 2 pi to 2 pi varies with n for different values of n. This thing also you require in while doing experiments in the lab. Okay, and also in your theoretical computations. So for example, in order to manipulate that parameter, how my function will look like, I will use another very important function, manipulate. Okay, few learners, they were having some problem with this in the last tutorial, so I thought I will just quickly recap. Okay, manipulate. Now open and close. What I would like to manipulate, I would like to plot sin x, but not this time, not sin x, sin nx. Okay, so plot, rest everything remains same. For plot also I have open and close square brackets. Here I would like to plot sin, again argument of sin will be in square brackets, n x. Okay, there has to be some space between n x, because if you write nx together, it will take nx as a new variable. Okay, sin x, nx, comma, a list, x varies from minus 2 pi to 2 pi. Okay, and then this is complete in itself. Okay, but I need to specify now what I would like to manipulate. Whenever you keep here your cursor, it will give you, Mathematica will give you that what is general syntax of this function. So it is giving you manipulate expression, and then whatever you would like to manipulate, you have to specify from where to where. So here I have specified only x, but I have not specified that from what value of n I would require the curve. So now here, so this square bracket is for the plot function. This is complete now, comma, again I have to make a list, n varies from 1 to 4, for example. Okay, and then I will run this, shift enter. Yes, very good. So I got a plot of sin nx. This was the same curve as I got earlier for sin x. Yes, but now as the value of n changes, I can see here, you can see here, as you change the value of n, the curve will change. Now if I require to change the value of n in discrete steps, okay, I don't want all the continuous values. For example, I require only 1, 2, 3, 4. So what you will do, here where you have specified from n 1 to 4, you can just specify comma 1. Okay, once again if I run this, then when you change value of n, it will take only discrete values. This is n is equal to 2. Again when you change, n is equal to 3, n is equal to 4. This is how your curve looks like. this is a very useful function which you can use to see lot of things. Okay, so this was all about the first part of our tutorial, which we have just recapped few things which we have done earlier in the first tutorial. I hope you all got some idea. Now you can just go back and see the full tutorial which we have done earlier. Okay, now let's move on to part B. So we'll try to see here. I would like to give a small section, okay, to input a matrix. Okay, now how do we input a matrix in Mathematica? So you come out of this cell, okay. Let us try to it is always nice to give a name whatever we are doing, some functions. For example, here you don't require plot, table, list plot, manipulate. But for example, if I'm giving some matrix and then I require that matrix to do further some operations, then it is always good to give a name. For example, I take A is equal to, how do we put a matrix? Let us try to take a very simple 2 cross 2 matrix. Then it will have 2 elements in first row, 2 elements in second row. A matrix is always put in Mathematica in the form of list. So here, open and close. Okay, I'll just change. And then inside this, for example, my first row has 2 elements. So I have 2 rows. Again inside this, one list, comma, second list. Okay, so this is my first row. It has 2 elements, 1, comma 2. This is my second row, for example, 3, comma 4. This is how you input a matrix in Mathematica. Okay, all the rows are given like this. For example, if you would like to check in Mathematica what does this stand for, how does Mathematica reads, then there is a very nice way of checking this: full form. Okay, again square bracket at the end, close. So the full form of this, list of list 1 2 comma list of 3 4. Okay, what I have just explained. Now okay, so let us try to once again input the same matrix. Okay, this is how you can input. If you would like to see its full form in a matrix form, so you can do like this: matrix form. Okay, so this is how you can see in the matrix form. But the problem is that when you write in the matrix form, you cannot do operations on this. So for example, if I want to find the transpose of this, okay, just I'm giving the name. So I would like to give the transpose, find the transpose of A. Okay, then it will not be able to do. When you remove the matrix form, once again you run this, and then if I find transpose, it will do. Again, you can check this in the matrix form. This is just to check, okay? In some time, it will become familiar like this. So this is your transpose. Earlier it was row 1, 2, 3, 4. Now it is 1, 3, 2, 4. Okay. This is how you find the transpose of a matrix. Similarly, what you can do, you can find the determinant. So what is the function for determinant? DET. So it is also always useful to give the name. So I can just write A. This is your determinant. You can just quickly check 1, 2, 3, 4. 4 minus 6, you should get minus 2. Okay. Then you can find trace. For trace, we use TR. That is the sum of the diagonal elements. Of A 5. Okay. Now I would like to find the inverse of A. So I am giving just the name INV is equal to inverse of A. Okay, this is the inverse of A. How to check? We know that A into A inverse should give me identity. Let us check that. A dot INV. Okay, so A is my original matrix and INV is the inverse of A. Shift enter. This is my identity matrix. Okay. So always you can cross check your hand calculations which you are doing with the matrices with Mathematica. Now next thing what you can do, you can also find the eigenvalues. Eigenvalues of A. Okay, we can just give a name EIG, anything, or not required here. So these are the eigenvalues. Then you can find eigenvectors, because these are the few things which you require quite often. So these are the eigenvectors of matrix A. So these are the few important things which you can check. Always remember how Mathematica is reading anything. You can check with full form. Then you can take transpose, find determinant, trace, inverse. One important thing I would like to tell you here, that for example, so basically when it is giving the eigenvalues of a matrix, it is given the form of a list. Okay, everything is in the list. So these are curly brackets, the first element of the list, second element of the list. Then here again eigenvectors, it is giving first element and second element. So let us name this as E1. Okay. Once again I'll run this. Okay. Now I need to do something with the first eigenvalue, and I need to pull out this first element of this list or first eigenvalue. How do I do that? So what you have to do, if you want to pull out any element from the list, so what you will do, you can also check, this is as full form, it will show you here. Once again I'll show you. Okay, this will tell you that how it reads. Okay, not required. Okay, I would like to pull out the first value. So E1 square bracket, inside this once again square bracket, and I would like to pull out the first value of this list. So what I will write? 1. Okay, shift enter. Yes. So what I got here, this was my list of eigenvalues: 1 by 2, 5 plus root 33, 1 by 2, 5 minus root 33, and I need, for my some requirement, I need to do something with first eigenvalue. How to pick from this list? This is the way that from the list I need to pick the first value. If I do here 2, it will pick the second value from the list. This is very useful command when you do some computations or you're making some code in Mathematica. Okay, so this is the second value of the list. And for example, you are defining some things. If you don't want to see the output, you can use semicolon, then it will not show you the output. Okay, so these are the few things which you can remember. Now moving on to part 3 of our tutorial, we'll try to check few matrices. Okay, again I would like to give some heading. You choose here section 3. Okay, so first we'll try to see symmetric matrix. Already in the course you have encountered what are symmetric matrix, that if any matrix is given to you, if its transpose is equal to that matrix itself, then it is symmetric matrix. Let us check that in Mathematica. Okay, so I choose some matrix, you come out of this cell. Now let M, or we'll write some sim. Okay, symmetric. Again, so let me take one matrix, a 3 cross 3 matrix. Okay, so I'll take a list. Inside this I have 3 lists, 3 rows. It's always good to make all the brackets, okay, complete. Now first row, for example, is 3 comma minus 2 comma 4. This is my first row. Minus 2, 6 comma 2. Second row. Third row, 4 comma 2 comma 3. So I have taken a 3 cross 3 matrix. Let us check whether this matrix is symmetric or not. How do I do that? So this is my matrix. First enter. Now I take transpose. Okay, so let me take sim t is equal to transpose of, okay, of sim. Enter. This is the transpose of yes. Now you can see that the transpose is same as the matrix itself. But for example, if there is some 4 cross 4, if it is clearly visible, or you can just quickly check sim minus sim t, what it should be. There is no need to do this, but still you can do that. So here the matrix and its transpose, they are equal. So you can quickly check that whether this is a symmetric matrix or not. Okay, Similarly, you can check antisymmetric matrix. Okay, here I can put 3a, 3b. So I'll quickly copy this and then I can make the changes. So here I put anti, and for antisymmetric matrices the matrix should be equal to minus of its transpose. Okay, I take another matrix as, so let us take a 2 cross 2 matrix. Curly brackets. If it is 2 cross 2 matrix, so I have 2 rows, comma, 0, minus 1, 1, 0. You enter this matrix, okay, and then I find the transpose, asym t. You can always put the names so that you remember what you're doing. It's always nice to put nice names in the code. Okay, this is equal to, I can just copy the from here. Okay, here I can put the this change. Sorry. Yes. So now you can see that it is negative of your matrix. If it is not clearly visible, what you can do? You can take minus 1. You can check minus 1 into ASM of transpose. It should give you back the matrix which from what you started. For example, if I do this, I got back the same matrix, 0, minus 1, 1, 0, 0, minus 1, 1, 0. So this is how you can check whether matrix is antisymmetric or not. Okay, so these are few very useful things. Now let us move on to another very important kind of matrix, that is orthogonal. Now I need to put the title. Okay, so what are orthogonal matrices? A matrix when multiplied with this transpose should give you identity matrix. Okay, this is equal to identity matrix. Okay, so now let us choose a set of orthogonal vectors. Okay, let us choose a set of orthogonal vectors. Okay, basically we should have orthonormal vectors. We'll check, okay, orthonormal vectors, then only they will form the orthogonal matrix, such that v1 is equal to, let us take 1 upon square root of 2. Okay, in Mathematica we write as sqrt, square root of 2. Okay, maybe I'll write this in the code. There's no need to write it here. So I'll come out of this cell and then I write in the code. Let me take the first vector as v1 is equal to, again as a list, first element is 1 divided by sqrt, square root. of 2. We'll see why we require the square root. 0 comma minus 1 divided by sqrt, square root of 2. Okay, this is my first vector. Then v2 is equal to 1 by 2, 1 by 2 comma minus square root of 2 divided by 2 comma 1 by 2. Okay, this is my second vector, and third is v3. My first element is 1 by 2 comma square root of 2 divided by 2 comma 1 by 2. Okay, very good. So now we have 3 vectors, and then I'll just enter. I have put the semicolons because I don't need to see these vectors, or you can remove the semicolons and check whether you have written correctly or not. So these are the vectors: 1 by square root of 2, 0 minus 1 by root 2, 1 by 2 minus 1 by root 2, 1 by 2, and so on. Okay, so let us check. Okay, check that these vectors are orthonormal. Okay, how do you do that? We can do that if the two vectors are perpendicular to each other, they are orthogonal. v1 dot v2 then v1 dot v3 v2 dot v3. Okay, oh, I forgot to increase the font of this. You can just increase the font if you're not able to see. Okay, these are the vectors. So I have chosen 3 orthonormal vectors, but I'll check. Okay, I want to write in the same cell. Yeah, v1 dot v3. Okay, just if you write in the same cell, it is good. Okay, you can see that this is 0. One more I can write here, v2 dot v3, and then you can write shift enter. So all 3 are 0. This tells you that all the vectors are mutually perpendicular. Now I can also check the normality. How? v1 dot v1 v2 dot v2 v3 dot v3. If you write in the same cell, it is easy to check. So I have chosen 3 vectors, and I have shown here that these vectors are orthonormal. Okay, so this is a quick check we have done. Now if we construct a matrix with these orthonormal vectors, then we'll see that that matrices should be orthogonal. This is the condition required for the matrix to be orthogonal. Okay, so now it's always nice to put the headings in your code so that you remember later on what you have done. Now construct a matrix with these orthonormal vectors. Okay, so how do I do that? Let us take O is equal to, you can always copy the vectors from here. Okay, comma, the second vector, second row, command C, then third vector as third row, comma, fine, and then we close the final bracket. This you enter, this is your O is, so it is giving symbol O is protected. It means that Mathematica has already used O as a inbuilt variable, so it's better to remove this. So for example, if I take M, I hope I have not used M earlier. Okay, so this is how the matrix, my matrix look like. Now if I take the transpose of this matrix, capital MT is equal to transpose of M. Once again, yeah, you run this, this is your transpose, and then I find M dot MT. That's what is my orthogonal matrix. This I should get as identity matrix. So this is how beautifully you can see that any set of orthonormal vectors, they will form a orthogonal matrix. Okay, so you can check all the steps in Mathematica. Okay, this is very nice. Also, you have encountered the positive definite matrix in your week 3, week 4 lectures. That also you can check here. For example, quickly you can check an identity matrix that obviously is positive definite. That if you multiply any vector, that V transpose vector with a positive definite matrix into V, that should give you positive squares. Okay, and here there is also an inbuilt function to check positive definite matrix that you can also directly use. So positive definite matrix Q. Here, for example, if you have done some calculation and then you would like to cross check whether your calculation is correct or not, you can always check here. For example, here I take M, or I take M dot MT. Basically this is M dot MT is an identity matrix. Okay, so true, that's what I expect, that my identity matrix is a positive definite matrix. Okay, and this you can check for any matrix. So this was all about how you can check different kinds of matrices in Mathematica: symmetric, antisymmetric, orthogonal, and positive definite matrix. And you can similarly you can keep on playing. Now let us move on and see how to diagonalize a matrix in Mathematica. Okay, so again I give a heading 4. Diagonalization of a matrix. Okay, so let us see. Now already, in order to diagonalize a matrix, we know that if I have any matrix, then I find the eigenvectors of that matrix and name it as P, and then P inverse and that matrix, and P, it should give me the diagonal matrix. This is a general procedure how to diagonalize a matrix. Let us check. So what we will do, we will take again the matrix which I have taken earlier. Okay, So for example, I'll take this symmetric matrix. Command C. But if you want to do the operations, you need to, I'll just change the name and I'll put this as X. Okay. So let me take again this 3x3 matrix and see whether I can diagonalize here. Now this is my matrix. You enter. This is my matrix. Okay. If you want to see in the matrix form, you can always write the matrix form of X. It will give you in the. Now I find I need a matrix with the eigenvectors. Already I have told you how to find the eigenvectors of the matrix. Okay. Yeah, very nice. So I got the eigenvectors of this matrix. Now I would like to find inverse of this. Inverse P is equal to inverse of P. So all the eigenvectors I have entered into another matrix P. Okay. The inverse of this is this. Now, how do I diagonalize the matrix? P dot X. I would like to diagonalize X. Okay. And inverse P. Very nice. So what do you see? That I was given a 3x3 matrix. I found the eigenvalues of those eigenvectors of that matrix, and then I have entered into another matrix P with the help of entering the eigenvectors. Then I found the inverse, and if I do Px inverse of P, I got another matrix which is diagonal. So fine, I have diagonalized the matrix X with the help of Mathematica. So this was all for today's tutorial, but we can do a lot more in Mathematica with the help of, for example, in week 3 and 4 you have done the example of you have seen the oscillations in triatomic molecule. All those calculations which we have done by hand, you can always go back and check in Mathematica. Okay, let us try to do some few more examples in the next tutorial. Okay, if you have any questions, you can write in the chat box. Okay, thank you for today.
Okay, thank you, Balaji. You can stop the video. So we have seen some few examples that how we can check different kinds of matrices in Mathematica. You can always post in the discussion forum or here in the chat box if you're facing any problem. And I would really recommend you that you all try all the problems which we are doing which are done during the course on classical mechanics in Mathematica. Okay, so we can also try to, you can also try to do the full triatomic molecule in Mathematica and try to see all different kinds of steps which you are getting by doing the hand calculations. Okay, so keep posting your questions, and I hope you're enjoying the journey of the course. Okay, thank you. Yeah, thank you, Balaji. Now, Balaji, you can stop the streaming.